Hi, my name is Susan Marie Terra. I am a doctoral candidate at New Jersey City University within their Educational Technology Leadership Program. Today I'll be talking about variability in statistics, specifically range, standard deviation, and variance. The following information that I will be using was gathered using Statistics for People Who Think They Hate Statistics by Salkin 2017. Variability illustrates how individual values are different from each other within a set of values. The following data sets were simply made up to illustrate variability. 1, 2, 3, 4, 5, 6 is the most variable because there are no two numbers the same. The next data set contains 1, 2, 3, 4, 5, and 5. This data set has some variability. The reason it is not most variable is because of the fact that numbers are repeated, such as 5 and 5. The third data set, 5, 5, 5, 5, 5, has no variability because of the fact that there are no different numbers. Variability shows that there's a difference in the values. You can compare how each individual value differs from the mean when you discuss and look at variability. So let's go into the Sherlock Holmes training room. The setting is a forensic science high school classroom. The culprits of variability will be range, standard deviation, and variance. The first measure of variability is range. It is indicated usually by a lowercase r. It is the most general measure of variability. It illustrates how far apart values are from each other. When would knowing the range be helpful in education? A teacher wants to know what the range of time it takes for her forensic science students to prepare for conducting a lab in her classroom. Knowing the range of time it takes her students to hand in their homework, place their belongings at their desk before they are ready to start preparing for the lab will be valuable information. This is beneficial because the teacher can then plan how much time is left in a class period to actually prepare for, conduct, and clean up a lab that her students participated in. Let's take a look at the following fictitious times to determine the range. To calculate the range, you will subtract the lowest value from the highest value in a set of values. From our example, we have 10, 10, 10, 9, 8, 8, 7, 7, 6, 5. Therefore, we subtract 5 from 10, and therefore the range in this example will be 5 minutes. In this case, the teacher knows she needs to allocate at least 5 minutes of class time for students' initial responsibilities upon arriving in her classroom. The second measure of variability is standard deviation. This can be seen as indicated as a lowercase s or a capital S and a capital D. It stands for the average distance from the mean. It is used to estimate something about a population and therefore must be done without bias. In order to do that, the steps discussed shortly will show us how to calculate the standard deviation in an unbiased standard deviation. The larger the standard deviation, the larger is the distance of each value from the mean in the data set, indicating that the data set has more variability. In fact, the larger your sample, the less of a difference there will be between a biased, the standard deviation of a sample, and the unbiased standard deviation of the population. The following values are made up in order to illustrate how to calculate the standard deviation and how it could be used in an educational setting. We will pretend that the values represent the minutes it takes forensic science students to settle into their lab groups at their lab tables, ready to start lab, which includes obtaining their gloves and goggles, reading their pre-lab, and obtaining the rest of their laboratory supplies needed as indicated in the pre-lab. I will now show you how to calculate the standard deviation. We're going to use the following data: 10, 10, 10, 9, 8, 8, 7, 7, 6, 5. Calculating the standard deviation takes place in multiple steps. The first step is to calculate the average. So therefore you add up all these numbers in the data set, and when you add them up, they equate to 80. Then you divide 80 by 10 because that's the number of values in this data set, and therefore the mean equals 8. So it takes about 8 minutes for forensic science students in this class to enter the classroom, read their pre-lab, and gather all their lab supplies. The second step in calculating the standard deviation is to subtract the average from each value in the data set. So if we begin with our first data value, we have 10 minus 8, which is the average, which equals 2. And this continues through the series, as you can see. The third step of calculating the standard deviation is to square each result. Therefore, with the first data point was 2, 2 squared equals 4. And you continue all the way through the data's values until you complete this step. The next step, the fourth step, is when you add all the squared results together. Therefore, you add 4 plus 4 plus 4 plus 1 plus 0 plus 0 plus 1 plus 1 plus 4 plus 9, and it gives you a total of 28. The fifth step is to divide the sum calculated in step 4 by 1 less than the total number of values in the data set. Since our data set has 10, you subtract 1, which gives you 9. Therefore, you divide 28 by 9, which gives you the value of 3.11. The sixth and final step is to take the square root of the result of step 5. Therefore, you take the square root of 3.11, which gives you a standard deviation of 1.76. If the standard deviation equated to 0, it would mean that all your values in your data set were the same and there is no variation. Since our data set came up with a standard deviation of 1.76, it shows that there is some variation. Now that we have calculated the standard deviation, you should note that if our data set had extreme values, which are called outliers, it would be important to note in your presentation or report because the standard deviation is sensitive to outliers. Therefore, since the standard deviation is a part of descriptive statistics, it is important to describe your data set, especially if outliers are present. Here is an example of an outlier. A student ran into a classmate who was upset in the hallway. After inquiring what was wrong and escorting the classmate to guidance, this student came into class a bit concerned for their friend and took longer to focus on the pre-lab reading and was not ready to start lab until 35 minutes passed. This value is much different than the 10 other values in the data set, and therefore it is considered an outlier. If a range was now calculated with this outlier, it would be 30 as opposed to the original 5. The third measure of variability is variance. The variance is equivalent to the standard deviation squared. We can use the same example we did for determining the standard deviation to calculate the variance. Since the standard deviation equaled 1.76, you have to take the square of that. Therefore, the variance equals 3.0976, which can be recorded as 3.10. The variance is easy to calculate after learning standard deviation. However, since the variance is used in other calculations in statistics and is often never used as a standalone value such as standard deviation, our investigation of range, standard deviation, and variance has been concluded. However, I will now show you how to make these calculations using SPSS. SPSS is a statistical computer tool that allows calculations such as range, standard deviation, and variance to be determined. I will show you how to use SPSS to find these values now. The first step is to put your values in the data table within SPSS. Now that your data is in SPSS, you have to click on Analyze, then Descriptive Statistics, and then Frequencies. Once in frequencies, you need to move your data to the variables column by highlighting it and then clicking the arrow to move it. Click on the Statistics button. In the Dispersion box on the bottom left of the Frequency Statistics tab, select Standard Deviation, Variance, and Range, then click Continue. Click OK. SPSS has now calculated the standard deviation, variance, and range for our dataset. SPSS is also capable of creating graphs for your data. This graph is a histogram of our data, which also illustrates the normal curve. As you can see, our data does not follow the normal curve. SPSS is also capable of showing outliers when creating a scatter plot graph, as seen here. The outlier is student 11, plotted at the top of the graph at 35 minutes. You have now completed this video on range, standard deviation, and variance, which provides statistical variability. Thank you for watching, and please select another topic to watch to continue your understanding of the case of the startling statistics. Thank you.